Hey guys, so this is 3-5 sequences and series. So this is kind of cool. This is looking at how things relate and looking at the series of those. All right, so there's really two types of sequences. There are arithmetic and geometric. So arithmetic are just ones that have some common difference. So that is adding or subtracting one number. Geometric is a common ratio. So that's multiplying or dividing by some number. So really what we're looking at is a set of numbers in a specific order. These are called sequences. So sequences are numbers that are ordered in that way for a reason. And the difference between these successive terms just means one that comes right after the other. And it's a constant value in an arithmetic sequence. This is called the common distance or common difference. So this is a constant value in these arithmetic sequences. All right, so the terms of an arithmetic sequence, the terms are going to be each value. So the values are separated by commas. You would have the first term, and then your second term, and then your third term, fourth term, and so on. And then you typically have these ellipses afterwards to tell you that the sequence doesn't stop, it keeps going. And you can tell the nth term of a sequence by you set this is equal to 1, this is equal to 2, 3, 4, 5. This is your first term. N is going to tell your first term. So even if these numbers weren't 1 through 5, they could be any number. But the first term is called n equals 1. The second term, the second number is n equals 2, and so forth. All right, so then you can actually use this equation to calculate any number in your sequence. So the first term in an arithmetic sequence is going to be a sub 1. So if you're looking up here, this is your first term, a sub 1. The common difference is the difference between your successive terms. So the difference between here is plus 1. So each time you're adding 1 to your term. So you could decide you knew that the next number would be 6 because you would just add 1 each time. This difference right here, your common difference, is called D. That's the common difference. In the nth term in a sequence, we use the subscript A and then the subscript N. A-N. So N is the nth term. So what this means is if you were wanting to find the fifth term in a sequence, it would be A sub 5. So these terms go A1, A2, A3, A4, A5, A6, and so forth, with commas between all of these. All right, so down here, I want you to determine whether the sequence is an arithmetic sequence, and then explain why or why not. So over here, we have 1, 3, 5, 7, 9, 11, and it keeps going. So what's the difference here? Well, you add 2. What about over here? Adding 2. Each time you add 2, such that you could predict what the next one would be if you added 2. And this keeps going. So then, just to clarify, this would be A1, this would be A2, A3, A4, A5, A6, so forth. Because this is your first term, your second term, your third term, your fourth term. So even though the numbers are not 1 through 6, these are going to be your terms. So A of 6 is 11. So is this an arithmetic sequence? Yes. Yes, it is, because it has a common difference of 2. All right, over here, I want you to write an equation for the nth term of the sequence. Okay, well, the first A1 is going to be 12. So A1 equals 12. All right, and then the common difference, what's our common difference here? We have 12 15, 18, 21, and so forth. Well, over here, you're adding 3. Here you add 3, still adding 3. You could keep going, and you're still going to add 3. So your difference then, D, is equal to 3. So let's use this equation up here. So A of n, so to find any term, you can take the first term, which is 12, plus n minus 1 times D, which is 3. So just to check, let me erase this so that we have a little bit more room. Write this up here. Okay, so just to check, if we wanted to find the, let's find the next value. So this is 1, 2, 3, 4. This would be a sub 5. If we wanted to find this value, a of 5 then is going to equal 12 plus the fifth value, 5, minus 1 times your common difference, 3. All right, so when this simplifies down, 5 minus 1 is 4. 4 times 3 is 12. 12 plus 12 is going to be 24. So this means this value is 24. Well, 21 plus 3 is 24. So we're good. So then this is going to be your equation for the nth term of the sequence. All right, geometric sequences, I said up here, had a common ratio, so you multiplied. We're going to get further into this in a later chapter. I don't remember which chapter it's in. So just so you kind of realize what's going on here, you're looking for a sequence that is arithmetic or geometric. So over here, what happens? Well, between 2 and 4, you add 2. Well, over here, what happens? Uh-oh, all of a sudden we're adding 4. So over here, what happens? We're adding 8. Okay, so let's try something else. What else are you doing from here to here? Well, you're multiplying by 2. Here to here, what do? Multiply by 2, multiply by 2. 16 and 32, what do? Multiply by 2. So in here, you're not adding, you're multiplying. You have a common ratio. So this is multiply by 2. So this is a geometric sequence. All right, over here, 120 and 117, what are you doing here? You're subtracting 3. Still subtracting 3. So over here then, in this next term, you would subtract 3. So this would be an arithmetic sequence because the common difference is subtracting 3. All right, over here, what are you doing here? Well, between these, you're adding a fifth because 1 is really 5 over 5. So 5 over 5 plus 1 over 5 is 6 over 5, plus 1 over 5 is 7 over 5, plus 1 over 5. So each time you're adding 1/5. So your common difference is 1 over 5. So this is arithmetic. All right, over here, what are you doing? Adding a half or multiplying by 2. So you're adding half or multiplying by 2. Over here, you're adding 1 or multiplying by 2. Over here, you're adding 2 or multiplying by 2. Well, the adding doesn't work. The multiplying does because you're multiplying by 2 each time. So you know this is geometric. All right, down here, all right, an arithmetic sequence is a linear function where n is the independent variable and an is the dependent variable. And you can write it as this function where n is a counting number. Okay, so really all this is saying, and the common difference is the slope, all this is saying is you can write this as a formula and actually graph it out to make predictions. And arithmetic ones are nice because it is a linear function. So for here, if there are 20 seats in the first row of the atrium, and there are 22 seats in the second, and 24 in the third, we have 20, 22, 24. What's our theme here? we're adding 2 each time. 26, 28. Each time we're adding 2. So the first term is a equals 20. The common difference we just found, so a1 is equal to 20. The common difference was 2. So if we were going to write this as a function, an then is going to equal 20 plus the difference in n minus 1 times the difference, which was 2, not d2. All right, 20 plus 2n minus 2, which would be 2n minus 18, if you were to actually write all that out. All right, so if we were to actually make an ordered pair here, when n equals 1, that's here, that's your first term, an was 20. When n was 2, it was 22, 24, 25. All right, so then we can go and we can graph this out. So 1, when n is 1, so n is here on this axis, and an is over here, so your value is over here. This is the number of seats, and this is the number of rows, really. All right, so 120, you had an ordered pair. At 222, 324, and at 426. Oh, I had 25 here. That should be a 6. Because you add 2. One thing I do want you to notice right here, that is a break in the graph. That means that they just didn't want to write a super, super long graph out, so they just broke it. So that's something to be aware of. Okay, so when you plotted it, this ended up hitting 18 too, at 0. All right, and so then you can also make a prediction. So if you were trying to say, okay, well, where would, when n was 5, which is here, where would it be? Well, you're looking right here. Oh, that's 28, which we said earlier was going to be 28.